Assalamualaikum, nama saya Siti Haliza binti Sabri. Nombor metrik 11 DKM 19F1063. Saya ingin membincangkan tentang virtual lab yang bertajuk Tensile Test on the My Skill. Objektif untuk Tensile Test ialah to study the mechanical properties of my steel specimen under tension load. Yang ini ialah data collection yang kita collect daripada eksperimen ni dan masukkan dalam table dan jadikan dia graph load versus ivory scale reading in millimeter, dan jadikan load versus extensometer reading. Untuk discussion, as a result, data material are those which can be drawn into wires. On the other hand, brittle materials are hard but they can withstand stress, so break instantly. The stress strain curve for ductile material covers more area as brittle material because of the reason that brittle material snap instantly. What do you understand by strain hardening? Strain hardening is generally defined as heating at a relatively low temperature after cold working. During strain hardening, the strain of the metal is increased and ductility decreased. Strain hardening is when a metal is strained beyond the yield point, and increasing stress is required to produce additional plastic deformation, and the metal apparently becomes stronger and more difficult to deform. Percent reduction of error is a ratio that expresses how much the specimen narrow when compared to its original size. It is calculated by dividing the difference between the original and new cross-sectional area at the point of failure by the original cross-sectional area of the specimen. Explains the step in the ductile fracture. The basic step in ductile fracture are void formation, void coalescence, also known as crack formation, crack propagation, and failure, often resulting in cup and cone shaped failure surface. Voids typically coalesce around precipitate secondary phase inclusion at a grain boundaries in the material. In a conclusion, the result of the experiment showed that the specimen undergoes ductile fracture because there was a reduction of area at the fracture point and the fracture appeared cup and cone, which conclude that my steel is a ductile material.
Assalamualaikum, nama saya Aqilah binti Arman, nombor metrik saya 11 DKM 19F1060. So, eksperimen hari ini yang saya nak terangkan ialah bending test on the mild steel. Objektif eksperimen ni ialah to study the behavior of mild steel rod subject to gradual increasing equal loads at 1/3 LT span and to determine its mechanical properties. Untuk data collection, kita dapat dia punya value yang ni. Lepas tu dapat graph, dua graph, satu load versus deformation at midspan. Yang kedua ialah average time reading versus theoretical deflection. Seterusnya ialah discussion. Untuk discussion, bending strength is defined as a material ability to resist deformation under load. It represents the highest stress experienced within the material at its moment of rupture. Next, in a 3-point bending test, the area of uniform stress is quite small and concentrated under the center loading point. In a 4-point bending test, the area of uniform stress exists between the inner span loading points, typically half outer span length. A ductile material is usually considered to have failed when it suffers unelastic failure. Brittle material fail by shear when compressive stress attain the maximum value. Untuk conclusion, the aim of this experiment is carried out to investigate the relationship between deflection and applied load. Bending machine has been used in order to measure the deflection of specimen. Based on the data and observation, the deflection of specimen is increased as the more force is applied for mild steel. From the graph, it showed that applied force is directly proportional to the deflection. Terima kasih. Untuk lab seterusnya ialah lab deflection of the beam. Objektif lab ni ialah establish the relationship between deflection and applied load. Determine the elastic modulus of the beam specimen from the deflection data. Data collection untuk lab 3 ni ialah ni data yang kita dapat daripada eksperimen kita orang buat. Untuk graph kita orang buat load versus experiment of deflection.
Ni calculation yang kita orang dapat untuk masuk ke dalam data. Discussion for the experiment. From the experiment, what is the relationship between the applied load and the resulting displacement? When load is higher, the resulting displacement is higher too. Second question, how the experimental result does differ with the theoretical in terms of accuracy? Theoretical value is the value a scientist expects from an equation, assuming perfect or near perfect condition. Experimental value, on the other hand, is what is actually measured from an experiment. Question number 3, give the example which related to the actual situation in the engineering area with the experiment. The example is flyover roads. So in a conclusion, from the experiment, it was known that the deflection was proportional to the load. The deflection was increasing as the load was increasing, and it increased with nearly the same dimension since the load was added up by the same weight each time. Also, the range between the load midpoint and deflection point affect it, and some other variables had relationship with it, such as Young modulus, second moment of area of cross-section of beam, and polar second moment of area. Therefore, the bending mainly depend on the load and the position of point that the load acting on them. Terima kasih. Assalamualaikum, nama saya Umairah binti Ishak. Nombor mencik saya sebagai KS 19F1015. Hari ini saya akan membincangkan torsion test on the mild steel. Objektif untuk eksperimen ini ialah to study the mechanical properties of mild steel under torsion. Ini adalah data collection yang kita dapat. Dia bagi graf. Lepas itu, daripada graf ini kita akan cari data-data di sini. Untuk discussion, what do you mean by modulus of rigidity? Modulus of rigidity is one of the elastic constant of material. The equation is only true as long as the material remains elastic. Second, define modulus of rupture. Define as the stress in a material just before it yields in a flexure test. Question number 3. How the angle of twist is measured in this test? By calculated with using formula. What does the brittle material feels in helicoidal shape and ductile material shares on right section under torsion load? Since brittle materials have minimum tensile strength, hence brittle materials fail in tension. Hence, brittle material subjected to torsion fails at 45 degree plane. Since ductile materials are weak in shear. The last question is, what are the different failure modes of the specimen? Failure of material under torsion. Ductile material falls in shear when subjected to torsion. Specimens will break along a plane perpendicular to its longitudinal axis, while brittle materials generally weak in tension than in shear. When subjected to torsion, a specimen tends to break along surfaces which are perpendicular to the direction in which tension is maximum. For the conclusion of the experiment, torsion failures are different from tension failures and normally provide little deformation or elongation. The characteristic of the fracture surface is related to the state of stress at the point on the bar surface. It can be seen that the maximum shear stresses exist along two planes which are perpendicular to each other. The characteristics of torsion fractures are influenced by torsional and tensile process. They result in two types of torsion failures. First, the type failure due to the shear stresses in mycel. Second, brittle failure occur due to the tensile stresses in mycel. Terima kasih.